Hey guys, how's everything going? This is JSer, who is not good at algorithms. In this video, I'm going to take a look at 689 maximum sum of three non-overlapping subarrays. We're given an array of nums of positive integers. Find three non-overlapping subarrays with maximum sum. Each subarray will be size k, and we want to maximize the sum of all three k entries. Return the result as a list of the indices representing the starting position of each interval. If there are multiple answers, return a lexicographically smaller one. So the input one is like this, the k equals 2. So we return 1, 2, 2, 6, 7, 3. So this sums up to the largest one. The nums will be 1, not be empty. Nums I will be between 1 and this. Here will be between 1 and the floor. So for this example, I think we better analyze the example for the simplest form with k equals 1. So if k equals 1, it means that actually we need to find three numbers which sums up to the largest one, right? For three numbers, maybe we find it maybe hard. Let's just rush it down to one number. Crush it down to one number. For one number, well, we just linear time, right? Just to loop through all the numbers and find the maximum. So it's no big deal. If two number, if we go into search for true number, what happened? Well, for two numbers, how many pairs are two numbers? Well, it's gonna be n times n minus 1, right? And we can sum them up, so it will be 2 and get the maximum. So this is a linear square. Could you improve it? Well, let's analyze the process. The first one, we pick a number here and search all the maximum, right? So actually, rather than we compare each pair, sum them down, sum them up, actually for the starting position at here, we only need to get the maximum of all these numbers, right? Now, if we pick a 2, we still need to get just to pick the maximum from this array, right? So now here's the tricky part. You see, we're checking starting at 1 and starting at 2, but we're getting the maximum of this array and this subarray, and these two subarrays almost is the same, right? It's only except the first one. So actually for that, if we go down to the last one, like 1, 2, and to 5, there's only one number left, so this one itself. So the problem becomes, for each position, we need to get the maximum of the rest subarray. And that subarray could actually be one linear time to get it from right to left. So if we cache the max out of subarray from right to left, we could actually, if we get the maximum, like maximum of from right for this index to the 1, and then we could loop from left to right and get the result, right? Like we're get 1, but we know the maximum of the right, and then get 2, the maximum of the right. So this will result could be improved to a linear time. Actually 2, but it's linear, right? Now here's the problem. If we get it to 3 numbers, could we reuse our idea here? Well, if we focus on the first one, it will be the same, right? Same as it will be the same problem here with 2 numbers, but with 1 left, right? And then we could this linear time, and then if we choose 2. But the 2 could be actually in the middle, right? It's already done. So actually, if we do it like this, it would be linear time for start index. It will be linear, right? Linear time for the start index, and for the rest, it will be linear. So actually, it will be O n to the square. But what if we choose the middle one, the three numbers, right? If you choose 2 as the middle one, then you see the left max and the right max, right? And now if we choose 1, and we get the left max and the right max, right? So now the left part and the right part actually is symmetric. So actually we could use one linear time to get the maximum from left to right, and use one linear time from right to left, and then use the last linear time to collect all the result, right? The final result. So actually we could improve the result into linear time, right? Cool. Let's start. So what we need actually is two subarrays is max array. Oh, there's a problem. So this is index. No, this is actually the of k equals 1, right? If k is not 1, is 2. Actually, you see that if we take a look at the start index, the sum actually could be reduced into one element, right? Into our case here. So first, we could split our implementation into how to say 4 steps. The first one is get crush it into k equals 1 array, and then collect the max array from left, max array from right, and then get the result by fixing middle element. Okay, the first one, the index array, right? So we could choose the, how to say, this is a because this is numbers, it's sums. For let I equals 0, I smaller than, it should be nums.end, because but k equals, if it is 1, it is 1. If this k, it's minus k, right? So yeah, a plus plus. So and we are getting the sum of 1 2 and 2 1 and 1 2. So we could use a sliding window to avoid calculating multiple times. Slide window. Okay. So let sum equals 0. Okay, for the 0, we sum them up. Sum nums I, and after we sum them up, like 1, okay, 3, okay, we need to push this element in, right? So if no, wait a minute. If I is for k equals 2, when we sum up to the third one, we need to subtract the first one. So if I is bigger than, is equal than k, sum actually will subtract the nums I minus 1. Oh no, minus wait a minute, this 2, so this is 2, we need to subtract this, so this is I minus 2, right? Zero, 1, 2, because k equals 2, so this one is minus k minus 1, minus 1, this is minus 2, yeah. Okay, this is the right sum, so sums push sum. So when we add a new one, if it is no, I is not starting here. I should be to the end, and we sum let I equals 0 sum the current one, and then when k moves out of k, we subtract it. But when we already push it, of course, if I is bigger than k minus 1, we'll start to push it. Right? We push the first sum 3 to it, and then go to the next one. We get 3, push it, and then get 3, push it. Cool. So this is the sums array. Now, the max array from left. Well, this should be inclusive. Okay, so let max equals infinity max from left for that I equals 0, loop through all the sums. If sums I is bigger than max, the previous max could be used as the current max, right? So actually we could max equals math max sums I. This is a new max, and max from left we push max, right? Max from left. Okay, we'll do the same from the right, but rather than unshift, I think we could just initialize, because the length hasn't changed. We could initialize it, and because unshift is very slow, array sums.length fill 0, and this is from right. And so okay, so here becomes this minus 1, it will be bigger than 0, minus 1, minus, this will max sums I, max from right, I equals max. Let's try to log the input, log max from left, max from right. We got a sum, right? 3, 3, 3, 8. Yeah, this should be right. Yeah, I think we got it right. And the last step, we fix the middle element and try to get the result, which is actually from the sums, right? So we will choose left. We could start from the, yeah. It's just 3 elements, right? Numbness will actually be 1. K will be, okay, K, so this will be valid. Okay, so max at last we set to infinity again for that I equals what? Equals, of course, 1. I smaller than sums.length minus 1. And maximum should be minus 2, right? Okay, now I plus 1. So the problem, the max equals max. Okay, so the left part would be sum max from left I minus 1 plus sums I plus max from right I plus 1. Finally, return max. Is not valid for input. Return the index, right? Oh my god. Okay. I know, we got the problem. So it's rather than the max, I think this should be max index. Max from left, you should push to the index. Okay. The index. If the index, I think okay. I'll just update the index. Max index. Oops. So if I equals 0, then it should be itself, right? Let's just do the same as this. Equals 0. Or we could just say 0 be 0. We start with 1 and say if sums I is bigger than sums math from 6 I minus 1, if it's bigger than it, then I equals I. If not, we will set it again to the previous one, right? This should work. And yeah, here is the same. If that's the case, it should be minus 2, and we set sums length minus 1 equals sums length minus 1. We set the same here. If sums I is bigger than sums max from right I plus 1, if it's bigger than it, then I equals I. In the other case, it should be the previous one, right? Yeah, and now we get this. Here we need to keep a maximum, and the result, let result equals null. Okay, so sum equals this, right? Sums plus sums I plus this should be max index from left. Max index. Yeah. If sum is bigger than max, max equals sum, result equals, of course, this, right? I. Cool. So at last we return the result. Wrong answer? What the? Like this, we output 3, 5, 3, 4, 5? Okay, we log the sums. Max index from right. Okay, the sum is, oh, we have a wrong answer of the sum. The sum is not, oh, sum is not right? Oh, sum is right. Like 3, 3, 3, yeah, 12, 6, this is right. And now the biggest, it says the maximum from left. Okay, we initialize them to 0. The first one should be 0. And I start from 1. This is sums. If it's bigger than the maximum 0, no. So it should be this previous one. Why 4? Where becomes? Oh, from left. Okay, 0, 0, 3, and 4, 4, 4. This is right. And now from right is 6, 5, 4, 4, 4. Yeah, this is right. So now we choose the middle. Start from 1 to this one. Okay, sums mean it equals the maximum index from left. Yeah, so here index is 0 plus sums I. Yeah, sums I equals sums I equals 3. Plus sums max index from right. Add plus 1. So we get this I. We forgot to update the math. Update it. Really? If sums max. Really? Update max for I. Sum. update max for 1. Some 0 is here, so it should be 3 3. Three, 19. Right? This 12. We got 33. This is 33. Log them up. We got 33. So the index is 3, 4, 5. Wait a minute. Sum is 33. Max index from left. I equals 4. Four. 0, 1, 2, 3, 4. Huh? Ah. Huh? Oh, ho, ho, ho. Huh? What's wrong here? Okay, so the sum 3, 3, 3, 8. There's no problem. For at 1, maximum is 19. So 0, 0, 1, 4. And then update 0, 1, 2, 3. We got 8 plus here 0, 0, 3, 4. This is 24. Now we get 13, 8. Non-overlapping, right? Non-overlapping. So we are going to do the sums is the array. We need to go to the non-overlapping. My bad. So if we got 1, 2, this is a sum, right? But it's overlapping. So when we are going to choose 2, we need to choose minus not 1, but minus. If it is 1, then it's 1. If it's 2, minus 1, minus 2. So actually minus k. Overlapping is something. God. the sums is actually start with the k, right? So it's okay, but each number, the sums array, each actually contains k numbers. So if you want to avoid overlapping, this is right. This is not right. Actually, I should not start from 1. It actually should be start from, where is it? If k equals 1, then it's from 1. If it's 2, it's from 2. Yeah, so k start from, I should start from k minus k. Yeah, I see. Overlapping is the problem. Sad. We got the wrong answer. Uh-oh. As always, let's log it down. See what we're doing. So the sum would be for 2, 3, 3, 3. Will be 1, 6, 9. There will be 8 3s, right? Okay, and then the maximum is actually to the left. And oh, I see what happened. When we are checking the right index from right, we are told to return the lexically graph smaller ones. So from left, we must check strict larger, but here actually could be equal. Yeah, wow, very tricky. Not valid. Oh no. Still we lock it down. Not a number? What? 1. The sums array isn't it right? Okay. Sum is 0. I is bigger than 1. Why I minus 2? It should be minus k. I am so stupid. Very tricky. Cool. Finally, we're accepted, but actually, I failed for like 3 times. The first time is about the sums. I forgot to handle the k very well. I write some dummy 1 or 2, and this next one is overlapping. I forgot the overlapping thing, and lead to mistakes here. And the last one, if there are multiple answers, return the lexicographically smaller one. So we need to choose the smaller index from left to right. It's so strict, bigger. But from right to left, if it's equal, we could update the index. So that's some tricky parts. And let's try to analyze the time and space complexity. As we already analyzed it, it should be linear time and space. Yeah, we use the sums array, the index array. So it's still linear. Cool. So that's all for this problem. Hope it helps. For this kind of array problem, what I learned from previous problems is that sometimes for maximum array something, consider sliding window to avoid calculating one by one. Like if you want to calculate the sum of 3 and adjacent elements, we just create a sliding window of 3 elements and move it left to right. So it will be linear time and calculate the sum array, which we are doing like this. And the second one is always considering caching the sum. Not only about this problem, but something like get the sum of subarray. We could actually do subtraction by subtracting the sums at I and the sums at j, right? And from left, from right, catch the sum, and there might be some leadings there. Another thing is about like the 3 elements, 3 sum. Fix the middle one, and it will lead us to the symmetric left problem, problem of the left part, and problem of the right part. So it's symmetric, and it will be just right, just be good enough to be the solution of caching the sum will be just perfect for these kind of cases. Anyway, hope it helps. See you next time. Bye bye.